So we have our f of x is equal to 1 over x, and then a is equal to 2. Remember that we formally refer to that as the center of the linearization. So one thing that you could do is you could memorize the formula for the linearization and then plug in a is equal to 2, the center. So you're looking at f of 2 plus f prime of 2 times x minus 2. And then you can compute what f of 2 is. So if I plug in f of 2, I would have 1 over 2, so 1/2. Plus, if I take my derivative of f of x, I would need to bring this up as x to the negative 1. And so my derivative would be equal to negative x to the negative 2. And to make sense of those negative exponents, we would put this down into the denominator as negative 1 over x squared. So if I plug in 2 into that derivative, I would have negative 1 over 2 squared, which would give us 4. And then x minus 2. Okay, so that is one formulation of our linearization that would be beautiful. So that is our linearization. Keep in mind that this is equivalent to using the tangent line approximation. So, or you could go through and you could find your tangent line. And if you find your tangent line, you would then solve for y. Okay, so if I take my tangent line, I would have y minus my y1 coordinate would be 1/2 equals, and then just like we talked about, our derivative evaluated at 2 would be negative 1/4, and then x minus 2. And then to get it into this linearization format, you would add the 1/2 to both sides. So we put the 1/2 in the front. And then this would be my linearization. So I would call this my L of x is equal to 1/2 minus 1/4 x minus 2. And so that's how you can use your tangent line to get to the linearization without having to memorize the formula. But again, either way is fine. If you want to memorize the formula, that preps you for knowing about Taylor polynomials, or you can use your tangent line and then solve by just scooting that constant over to the right-hand side.